If we have the function square root of 2 times cosine x plus x, as we had in the previous video on local max min, and we wanted to find the inflection points of this function, we would do that with the second derivative. So we found the first derivative when we were finding the local max min. We then take the second derivative. The derivative of sine is cosine, so the negative square root of 2 would stay in place, plus 1, the derivative of 1 is 0. And then we would want to set that equal to 0 because our possible inflection points occur when the second derivative is 0. So solving this equation, we would divide by negative square root of 2, and that would give us when cosine of x equals 0. Well, solving cosine of x equals 0, that you cannot draw triangles for that, but what you can do is look at the cosine graph itself. From 0 to 2 pi, the cosine graph looks like this. It is 0 at pi halves, and it is 0 at 3 pi halves. So our possible inflection points are at those locations. Those are what we would label as possible inflection points. To show that they are actual inflection points, we must show that there is a change in concavity on f. And the way to show that is show that f double prime changes from positive to negative or vice versa. So therefore, I'll label my sign chart f double prime, put on my possible inflection points, pick numbers over here as like 0 and pi is in between there, and 2 pi would work good over here. I need to plug these back up into my second derivative. So taking 0 and putting it in for cosine, the cosine of 0, of course I can look back over here, cosine of 0 is 1 times the negative root 2 is negative. Cosine of pi, if I put pi into this second derivative, cosine of pi is down here at negative 1 times the negative root 2, that's a positive. And if I put 2 pi, cosine of 2 pi is 1 times negative root 2 is negative. So this tells me that f double prime is concave down, this tells me that f is concave down, then concave up, then concave down. So therefore, pi halves and 3 pi halves are inflection points. I would need to write down that pi halves and 3 pi halves are inflection points of f, and the reason they are inflection points is f double prime changes sign, therefore f changes concavity. Writing that down would be my rationale that pi halves and 3 pi halves are truly inflection points for this particular problem.